Okay, here is the quotient rule, and if you follow the directions at the end of the last video, it told you to watch the quotient rule song that I have under the YouTube portion of my Moodle, and that is because it's a catchy little tune that will help you remember the quotient rule. And I found in the last couple of years after showing that I would find my students actually singing it, and it would help them remember how to do the problems. So let's kind of just talk about what the word quotient means. Quotient means the answer to a division. So once you recognize that there's a division problem going on and you need to find the derivative, think of the quotient rule song and it will help you go about the problem. So if you have a quotient in the form of something divided by something, as long as your denominator is not 0, you're allowed to take the derivative. And in order to take the derivative, according to the book, here's the rule. So I kind of shortened it and I did f prime g minus f g prime. And I'm going to write it this way. It's the same thing as saying f prime g minus g prime f. Notice that g prime f g prime, same thing, all over g squared. And this is why I had done the product rule slightly different from the book, because it was getting you ready for this quotient rule. Remember, the product rule said f prime g plus g prime f. This one's f prime g minus g prime f all over g squared. So you're going to do the normal situation in the numerator, and this all over the denominator squared. So in this problem right here, I recognize that these are both binomials, and it's in a quotient type problem. That's a division problem, so I need to figure out the quotient. So I'm going to use the quotient rule. So the derivative, okay, remember the song is low d high minus high d low. Low means the bottom. Take the low. D high means derivative of the high, derivative of the top. So derivative of 3x minus 2 is just 3. Minus high is the numerator, times d low. D low means derivative of the low. Derivative of 2x minus 3 is just 2, all over the denominator squared. So remember, it's low d high minus high d low, all over the denominator squared. So now we're going to simplify. We're going to distribute these. So we'll get 6x minus 9. We'll go ahead and distribute these. But remember, there's a minus sign out in front. So that would be negative 6x. Right here would be a negative 4, but there's a negative right there, so it would be a plus 4. And then those will cancel. Negative 9 plus 4. And we are done. There's our derivative. Same idea here. Notice that I cannot cancel these out. Remember, it's sine x, 1 unit, divided by just a single x. So there's nothing I can do. I'm trying to find the derivative. So I recognize that it's a division problem. So I'm going to use the quotient rule. Okay? Low d high minus high d low. Low is this. Just take it the way it looks. Times the derivative of the high. So what's the derivative of sine x? That would be cosine x. Minus high, sine x, times the derivative of the low. Well, the derivative of x is just 1. All over your denominator squared. So what I have here is x cosine x minus sine x times 1, which should just be sine x all over x squared. There's nothing I can do right now because this up here is a binomial. Now it'd be nice if there's an extra x out in front. I could factor out an x, but there's nothing I can do. All right, let's take a look at this one. Okay, it's a division low, D high, minus high, D low. So low, derivative of the high, so the derivative of my top, minus high, D low, derivative of the bottom, all of the bottom squared. Well, x times 1, just x. 1 times x plus 1 is just going to be x plus 1, but there's a minus sign there. So remember, I have to distribute. Those cancel, and I have this. Now let me just kind of show you an alternative. We talked about one of these earlier in the different lesson. There is an alternative, and I'm going to show it to you here because there are problems where you could do it several different ways. I could just simplify my problem first. Remember when you have a bunch of stuff up in the numerator all divided by the same denominator, you can just separate them? It's the same as saying x over x plus 1 over x, which is really just 1 plus 1 over x. Well, if I want to use a power rule, I'd have to rewrite this as 1 plus x to the negative 1. Remember, I'm going to bring this up. So now if I take the derivative of 1 is nothing. Power rule here, I bring this out in front, and I drop down a power. And then I have to rewrite it. This needs to drop down now as x to the second. So I want you to see that you can get the same answer, but there's a lot more work involved in this way.